Good afternoon and welcome to our webinar, The Evolution of 3D Printing with EnvisionTEC. My name is Madeline Holzer. I'm the Education Events Specialist here at Zahn. And we are joined today by Chris Rose, the Director of Dental Channel and Sales, and Miguel Gomez, the Tech Services Manager at EnvisionTEC. Just keep in mind, at the end of our presentation, we should have time for some questions. You can go ahead and put your questions in the chat, and we'll be happy to address them as time allows. Welcome, gentlemen.
Thank you.
Hello, thank you.
Awesome. All right, so thank you for that, and welcome everyone to today's webinar. In this webinar, Chris Rose and I will present a full introduction to EnvisionTEC's latest technology, or one of EnvisionTEC's latest pieces of technology, the EnvisionOne CDLM. This will be, like she said, a 45-minute presentation, and we'll have 15 minutes for Q&A at the end. So let's jump right in. And so the first thing I'd like to do is present Chris Rose, the Director of Dental, the Dental Channel for EnvisionTEC North America. Chris has been with the company here for 5+ years, and he's been driving the dental team forward and delivering best-in-class solutions to our customers. Chris Rose, how are you?
Hey, good. Thank you, Miguel. Thank you for the generous introduction. Well, thank you all for taking time out of your day to spend a little time with myself and Miguel. We're really excited about where EnvisionTEC and our 3D printers and materials are going and evolving within the dental space. So we're excited to not only bring you up to date on the hardware, the printers themselves, but also our material portfolio, as well as a little peek at some other materials that are forthcoming. Next slide, please. So to kick things off, I think it's important to let everyone know just what our mission at EnvisionTEC is. We want to shape the future of additive manufacturing, offering not only best-in-class solutions that dream on, on the dream of 3D printing, but most importantly, that can be fast, cost-efficient, personalized, and of high quality. And this is for both large and small use, so that they can together be affordably brought to market. Go ahead, Miguel. So first, I wanted to touch on a few of the markets that EnvisionTEC is in outside of dental. I think it's important for our dental users to know just how widespread the company is, the different industries and technologies that we work within, because in many fashions these do end up relating to dental. In our industrial space, we're working with some key aerospace and automotive end users, certainly prototyping, low volume production, and even in the foundry industry, we have a 3D printer that prints large molds made out of sand for casting in the foundry industry. Next slide, please. So within the professional market, we have jewelry, entertainment, and education, and we'll go over a variety of some of those users in a bit. Next slide. We're also outside of dental and other medical markets, such as bioprinting with our bioplotter, many other medical devices as well. Next slide. So to give you an idea of just how diverse our customer portfolio is, if you look at the medical side of my slide here, I think you'll see some names that you all recognize, like Mayo Clinic, Northwestern University, Cleveland Clinic. In the dental space, of course, Glidewell, Forestident, but in audiology and other medical devices, we also have end users such as Senhere and Phonak, just to name a few. In the professional space of jewelry, many well-known jewelers are 3D printing, such as Tiffany, Cartier, Shinola, and even in the entertainment space with companies like Disney, Pixar, Hasbro, and Apple. Across the country, we also have many educational facilities such as Harvard, Purdue, University of Maryland, just to name a couple. Within the industrial space, many manufacturers such as Ford, Boeing, Lockheed Martin and Hyundai are using EnvisionTEC printers. Same with production and prototyping from companies like LG, GE, and 3M. And as I mentioned, in the foundry industry, we have the ability to 3D print these large sand molds that are being used by companies like Trident and Hazelton. And within each one of these markets, there are many sub-markets, again, under medical, in-ear devices, orthodontic, medical devices for other parts of the body, within industrial, besides what we've touched on, even appliances and consumer goods. Professional, again, on top of jewelry and entertainment, we also are active in the education space. Next slide, please. But for your dental practice, there's really only one printer that you need, and it's the EnvisionOne. This is the original patented continuous digital light manufacturing system. It allows us to introduce oxygen within our 3D printing. Next slide. Now, you may ask, why is that so special? Well, when we introduce oxygen into our 3D printing, this allows us the fastest, highest level of accuracy and resolution and zero separation forces. What that means is when the oxygen is introduced to our printing, we eliminate the typical layering and visible striations that you may commonly see in a lot of dental parts. So this allows us to offer the highest accuracy desktop printer, but it also allows us to print large parts flat. We are well over 4 times faster than the standard DLP printer and over 10 times faster than the typical desktop SLA printer. Now, speed in large parts is fine, but what's even better is to be able to maintain a highly accurate part that offers better mechanical performance. And what I mean by that is when our parts come off of the printer, we have maintained the same level of strength in the X, Y, and Z axis. This is known as isotropic properties. Very, very important. The EnvisionOne is the only desktop printer that can offer that. And again, we offer the largest build platform at the fastest speed, so it'll really handle a lot of daily throughput. Next slide. So when we talk about fast, just to give you an idea, and this slide is a little bit dated, but it'll give you an idea. The EnvisionOne printing at an average of 50 millimeters per hour. As I said, this slide's a little bit dated. We now have some new materials, some new software upgrades that are actually allowing us to print some model materials in excess of 100 millimeters per hour. Again, this depends on the type of material and the layer thickness that you're printing, but you'll see versus the average DLP at 12 millimeters per hour or the average SLA printer at 5 millimeters per hour, this really is a much faster based process that will allow for a lot more daily throughput. Next slide. So here, Miguel has running a full build plate, and you'll see that we're completing these parts in about 24, oh no, was it 24, 25 minutes, I think, Miguel? And yep. The EnvisionOne, again, we're now have surpassed 1 millimeter per minute. We have layer thickness options that go from 5 microns up to 150 millimeters or microns, depending on the material. Just to give you an idea, this means printing a full tray of dental models at 50 microns resolution in 30 to 45 minutes. If you were to move that to say 100 microns, you now have the ability to print dental models in the 15 minutes or less space, depending on the material. A full tray of implant restorations in less than an hour. So also equates to give you a visual of 10 to 14 drill guides in 1 hour. And again, a large build platform, 182 by 102 millimeters, which is the equivalent to like 7 by 4 inches. Next slide, please. So while hardware and equipment is good, materials is even more fun. We have the largest industry-leading portfolio of materials for 3D printing. In dental now, I think we've surpassed 24, 25 different resins. Dentures for the base, denture teeth, a variety of models, including crown and bridge model material that allow for really beautiful quads with removable dies, indirect bonding trays, surgical guides, a large variety of models for thermal forming. And we actually have a new one coming out called the E-Aqua model. And what is really unique about this for orthodontic models is within the name Aqua model, we are able to water wash this model material after it comes off the printer as part of our post-processing and eliminate having to wash the models in an alcohol bath. So instead of an alcohol bath, it's a fresh water bath. And there'll be a lot more information coming on that. We also have ortho models that no longer need a separator medium for your salt and pepper Hawley model techniques. Night guards, a variety of nice, clear, hard, or soft, gingival masks, partial denture frameworks, including our new metal-free partial. EnvisionTEC is also one of the only companies that can produce castable wax-ups for crown and bridge work. A variety of bite splints, again, both hard and soft, as well as custom impression trays. Next slide, please. Now, in addition to those materials that EnvisionTEC produces, we do actually work with other quality manufacturers as well. And this is to ensure high quality. So in EnvisionTEC, we have a new selectively open approach that allows us to partner with other material manufacturers that offer a medical grade end use industrial materials that are going to meet our standards for usability and effectiveness with our printers. Now, just some of those are names like Keystone, Henkel Loctite, NextDent, DTax, and Somos. So we have a wide range of materials to go with our variety of printers as well. Next slide. And I think we're up to Miguel. So with that, I'll turn it over to our tech guru. Miguel, it's all yours.
Thank you, Chris, and hello, everyone. Again, I just want to repeat for Chris, thank you all for taking the time to join us and to hear what we have to say about the evolution of 3D printing in our eyes. I'm super excited to talk a little bit more about. I'm just going to basically take what Chris Rose has given you guys and go a little bit deeper into the nuts and bolts as to what makes our technology what it is today. And I'm also going to be talking a few things about software features and also a new site that we're excited for everyone to start using. So without further ado, again, I'd like to present myself. So my name is Miguel Gomez. I am the tech services manager for EnvisionTEC. I've been with the company for about 7 years now, and I've grown, with the company from knowing very little about additive manufacturing to now being able to speak to you guys about it. So it's very exciting for me. And again, thank you all for joining. So let's talk a little bit about DLP technology. So to understand the EnvisionOne CDLM, before we go into that, I would like to break down a little bit about what is DLP and what is CDLM. So EnvisionTEC was founded in 2002 with the release of the first DLP 3D printer. It was also the first printer capable of printing wax. EnvisionTEC since then has become a global provider of professional grade 3D printing solutions with 6+ now process platforms and 45+ model configurations. And it's, obviously we've been growing since then. And we do have we do have printers like Chris was showing you guys. And this is one of those things that we were talking, Chris and I, about this presentation. And we were like, we love to talk about what we're doing in dental, but I think especially for people that have our equipment, we would like to talk a little bit as to, okay, yeah, you have your printer maybe in a lab or on a chair side, but let's talk a little bit about other stuff that's happening with the exact same printer, all the different industries it's being used in, from different technologies, different applications, the military, from audiology, all those different things. It just shows you the versatility of this equipment and what it's able to do. So yeah, we got dental, audiology, bioprinting, aerospace, automotive, jewelry, entertainment. It's the board is all over the place for us. We're in really any and all market that can use a 3D printer. I feel like we're in. But let's dive a little bit deeper into DLP printing. So DLP uses a high definition projection system to quickly stamp out a full exposure or a full image at a time. This makes it much faster than traditional SLA desktop printing. So what I mean by that is, basically what happens is instead of a laser drawing, a line and kind of tracing out the entire object, the DLP, the projector just kind of shines the entire object all at once, and in a matter of seconds, you have the entire area covered versus having to wait for the laser to kind of go through and stamp out the whole image. But there, we're not the only DLP company since the inception of the DLP printer. There have been other people that have come to market, but EnvisionTEC has many different advancements in DLP because we were the originators. We have put a lot more work into it. We have a lot more experience with it. And so we have things like patented contour grayscaling, which can control the degree of white and gray in each pixel, allowing for a smoother surface finish and extreme accuracy. So instead of us being able to, illuminate the entire pixel 100% of the time always, we're able to control that light and be able to, instead of shining a full pixel, shine less of full pixel, giving us better resolution and giving us better accuracy, which we're going to dive here in a bit. We're going to dive a little bit deeper into accuracy versus resolution. What's the difference, and what am I really trying to get, and what am I looking for? So here in the diagram in the slide, we see a representation of the DLP process. So we have the light source, which is shown here towards the bottom. You can see it with all the highlights. We have precision optics, light source, DLP chip lens. That entire thing is the DLP projector. So this light is projected from the light source through the precision optic onto a DLP chip through a lens and into the resin or into the material tray. This entire process literally happens within a few seconds. Or actually, the actual process of the projection happens in under a second. It happens in milliseconds. But again, going back to what makes it fast and what makes it accurate is it happens all at once. So you cover your entire space and you cure that entire layer within a matter of seconds instead of having to trace. So, and you can see in this picture here, this is an upside down process. So you have your projector at the bottom, you have your material tray, and then you have your platform on top, and the projector shining up, the platform's coming down, and we have, again, called that top down, or the bottom up process, the bottom up printing process. So that's DLP. That is basically the fundamental of DLP. You have a projector, you have a resin tank, and you have your platform, and then you print. That's the entire basic, breaking it down into simple terms, that's the entire process, right? Well, let's talk a little bit now about, let's talk a little bit about the 3D printers that we offer and what different technologies they use. And then after this, we're going to talk a little bit about CDLM, which is a twist to DLP. So on the left side, we have the Vector 3SP. So 3SP utilizes a laser to rapidly scan, spin, and selectively photo cure resin in a unique approach that is actually proprietary to EnvisionTEC. We're the only company that offers this solution. And basically what we're doing is, instead of having, because we're talking now large platform printing, so large build envelope. Instead of us having to take this entire large build envelope and then using a laser beam, again, to trace the entire platform layer by layer by layer, what we do is we have a laser head unit that has, again, selectively, that has a motor inside with lenses, and it's a very complex piece of equipment. The laser moves, and as it's moving in the x-axis, it's actually plotting out points and drawing an entire line in the y direction. So it's moving in the x, drawing in the y, and we're able to scan the entire platform instead of it taking, again, much longer with one small dot tracing the entire platform. We're moving an entire laser head assembly, keeping it completely parallel to the material, and we're able to get better surface definition, and we're also able to do it much faster. Now, next to the Vector 3SP is the P4K. This is the newest release in the Per Factory series, the P4K LED. This uses a 4M pixel projector and artificial intelligence with pixel tuning to deliver extremely high quality models. We're well known for our Per Factory series. It's it's one of our oldest lines of equipment, but this is one of the newest of that line. Again, offering 4M high quality technology. To the right of the slide, we have our desktop family. So we have in the center our Vita, which is one of EnvisionTEC's best-selling 3D printers for the dental industry. We have the Micro Plus XL to the right of that Vita. And then we also have our CDLM, which is CDLM, or continuous digital light manufacturing. So EnvisionTEC first filed a patent for continuous printing in 2006. This patent was granted in 2011, 5 years later. The Micro Plus CDLM was released, closely followed by the Vita CDLM, pictured to the left here. So if you have this, the gray printer, the Vita, right next to it we have our Vita CDLM. It is a build envelope of 145 by 81, making it slightly larger than the standard Vita. But the CDLM uses reduced separation forces, which I will talk about a little bit deeper here in just a bit. And it just makes it so the processing time is faster. And again, like Chris was saying, the isotropic properties, or the adherence of each layer within itself, is much better. So let's now talk about our EnvisionOne CDLM here at the center stage. So this is the latest in the CDLM family with a massive build envelope of 182 by 102 millimeters. The EnvisionOne CDLM is the largest, most advanced desktop 3D printer really ever created. It is bigger, faster, and easier to use, and also more innovative than most other 3D printers on the market. The EnvisionOne is CE certified. It has Canadian certification and has very short lead time. So let's talk a little bit more about what CDLM is, because I do want you guys to understand the entire the technology behind this printer and what makes it so advanced. So CDLM, or continuous digital light manufacturing, speeds up the DLP process by adding a thin layer of oxygen between the layer that's being cured and the material tray. This layer of oxygen inhibits the resin from curing, which in turn adds many exciting properties. So the first advantage is speed. The DLP process, which requires one layer to be exposed at a time, with pauses in between to make sure the prints or the layers are separating and repositioning the build platform. See, the oxygen is utilized in the CDLM technology to reduce those separation forces. So when we're separating, we're not adhering to the basement. And this makes it a faster print, because again, we don't have to pause and wait for material to displace. We don't have to worry about separating from any type of film. And also makes the pauses in between, so when you come down and you're ready for the next layer, you don't have to wait for that material displacement because it happens so fast. So in turn, this cuts off the time needed to build each layer, and overall, the print time for an orthodontic model on the EnvisionOne is 30% less than other, let's just say, pricey oxygen-based printers on the market. So the second advantage of CDLM printing is accuracy. Parts printed on the EnvisionOne have isotropic properties and consistent part properties in all dimensions. This is especially important in the Z because in prior 3D printing methods, while not all have the same quality, they have, so with traditional 3D printing or traditional DLP printing, when you're adhering one layer to the next, what ends up happening is when you separate your layer, right, after every single layer is projected and printed, when your platform goes to separate, there could be a tearing that happens after every single print. So when your platform comes back down to adhere the next layer, the adhesion between layers cannot be as strong. So what ends up happening is you have X and Y strength of X, and then you have less strength in your Z. Now, with the EnvisionOne, again, we don't have to deal with this issue, and we actually have a much better or an equal amount of strength in both X, Y, and Z, because again, we're not even separating away from a film. We're just lifting up to where enough material is back and in position, and we're curing the next layer. So we're moving very fast, and there's no tearing that's happening in between layers. So, and then parts printed continuously also do not have any clear weak points. So this makes it so that in dental, with your isotropic properties, you have incredible strength for long-term uses in the mouth, kind of like dentures. You have bite guards. You gain all this strength thanks to the isotropic properties you get from your CDLM or your oxygen-based equipment. Now, when I say oxygen-based equipment, we're not the only company out there that has oxygen-based equipment. So let's talk a little bit about common continuous 3D printers. So common continuous 3D printing systems have been on the market today, and most of them have oxygen placed typically below this rectangular piece of oxygen permeable film that covers the entire build envelope. As you can see in the display, that's the part that's bubbling up here on my presentation. So this film allows just enough oxygen to penetrate through. So if you see in my presentation, you see the oxygen labeled by the blue O2s, and then there's this white layer right above that blue film. That is what's called the oxygen-rich liquid zone. The zone is the area where the oxygen and the photopolymer live together, and the oxygen inhibits the polymerization. This means that nothing gets cured directly onto the film. So in essence, the parts are kind of printing floating in the material. Well, obviously, they're sticking to the platform, but again, there's no real adhesion happening to the film. Now, unfortunately, adding oxygen below a flexible film inevitably causes the film to tent or rise more in the center than in the outer edges. This means that the film has a dome shape during the printing process, and the oxygen-rich liquid zone or the white zone here, the oxygen-rich liquid zone, is also domed. Excuse me. This in turn means that the parts are no longer 3D printed on a flat surface, and I'm sorry. This in turn means that parts are no longer 3D printed on a flat surface, even in the free space above this rich liquid zone. Referring back to this diagram here on the slide, we can see that the dome causes visible variation across the build platform of about 400 microns, or almost half a millimeter, which results in inaccurate parts. And we'll talk a little bit more about accuracy towards the end of this presentation, where I have some scans that kind of show how this dome or how this deviation really affects your prints. So how did EnvisionTEC battle this dome? Well, we brought out what's called the domeless material tray. And what this domeless material tray does is that it creates this flat level playing field for the material to kind of sit on. And we also have a completely flat oxygen-rich liquid zone. So as you can see, we still have the exact same idea. We still have oxygen flowing through. It's still permeating through the film. We still have an area where the materials are kind of floating above the resin and not actually adhering to the film. We still have this entire technology. However, we don't have a dome effect. We don't have to compensate for it. We don't have to fight it. It's completely flat. So this is still just like traditional. We're taking the best things about traditional printing, taking the best things about continuous or CDLM printing, and combining the two and bringing to the market the most advanced piece of CDLM technology or continuous technology. So again, just to reiterate, on the slide, we see a diagram of the domeless material tray in action. The dome effect has been completely removed, and in its place, we have a flat, even material tray surface and a continuous line of oxygen-rich liquid zone, and even accuracy across the build envelope with a maximum deviation of plus or minus 50 microns, which is really not much at all. So let's give you guys a little sneak preview or an idea as to how this domeless tray really actually works. So on the right side, we have an exploded view of the EnvisionOne CDLM domeless material tray. Beginning at the top, we have an oxygen permeable film, followed by a material chamber, and below the chamber is the oxygen chamber. The vent holes allow oxygen to enter and exit the chamber in a regulated manner. The glass panel is the final part of the assembly located on the bottom of the domeless material tray, and the light is projected through the glass panel, through the oxygen chamber, through the film, past the zone, and onto the resin in the chamber, and finally onto your part or your platform. So as you can see, it's definitely a very, very complex piece of equipment, making it, again, some of the most advanced CDLM technology on the market. So now let's talk a little bit, now that we've covered all that is continuous, all that is oxygen, let's talk a little bit about the projector and what makes the projector special in the EnvisionOne. So with continuous printing, the light intensity must be powerful enough to penetrate the oxygen-rich liquid zone and relay enough light or energy to the resin above this zone in order to build models accurately and as quickly as possible as the platform advances at much faster speeds. This brings us to, again, this 385 nanometer projector. It's currently the most 3D printers on the market use a 405 nanometer projector or a 405 nanometer wavelength light source, which has been designed for standard film projection. The industrial 385 nanometer wavelength projector being utilized by the EnvisionOne was designed specifically and optimized for 3D printing. This projector is an LED light source that does not require any warm-up time and does not require lamps to ever be changed, which is, again, less consumables, the more affordable it is for the lab or the customer using the equipment. So what else is nice about 385 nanometers? Well, because it is a shorter wavelength than 405, this results in a more precise printed model and overall better accuracy. A shorter wavelength focuses the curing field, where with a 385 nanometer wavelength, 96% of the part is cured in its green state, so right out of the printer. Whereas with a 405 nanometer, you're only curing about 80% of the way with the green state. This leads to light bleeding and curling issues. 405 nanometers also has a higher chance of curling during the post-processing. This is due to 80% of a cured green state model that is produced by the printer. And when I say green state, I mean a model directly off of the printer after it's been printed without post-curing. This is what we call a green model or a green state model. With 385 nanometer wavelength, the green model is cured already to a 96% curing state, which only leaves 4% of curing for the post-processing. This reduces the chance of curling by almost 5 times, and the light bleeding effect of exposing the light and curing material outside of the targeted area is much, much less, as seen here on the slide. We can see that the surface finish of a 385 nanometer projector has much less bleed out into the vat or into the material tray versus a 4 or 5 nanometer projector. So with translucent materials like E1 Guard and E-Guide, we also have, the 385 nanometer LED projector gives us a clear surface finish. With EnvisionTEC's patented contour grayscaling, the technology gives us one step further, allowing for an XY resolution boost from the native pixel resolution of 93 microns to 60 microns. And I'll talk a little bit more about accuracy and resolution in a further slide, because we do believe it is an important topic to discuss. So let's talk a little bit more about what's offered by the EnvisionOne when it comes to its build. So the EnvisionOne does feature a dual linear slides on the Z-axis assembly. This gives the build platform superior stability and control throughout the print, and eliminates shift lines during the print for the printed model. For data transfer, we also have both wireless and wired capabilities, and also so we offer both wireless and wired capabilities. So if you don't have an Ethernet cable, you can hop on your wireless network in your lab or in your office and connect to the printer wirelessly. If we look, we also have USB ports on the printer, and there's plenty of them. There's 2 in the back and 1 in the front. So if you don't have a network that you can use, whether it's wired or wireless, you have an easy access port in the front of the printer to be able to transfer your jobs from your PC to the printer itself. Also, the EnvisionOne shows off a brand new user interface called the DLP CS, or DLP controller software. That it is extremely user-friendly. It's a 7-inch touchscreen display that works beautifully, and it has a simplified controller software with iPhone-like icons. The controller software also prompts the users whenever there is a new update, and the operators can also choose not to use the touchscreen and instead connect a USB mouse and navigate the screen. Now, let's talk a little bit about the build envelope. So, like we said, we do have a pretty large build envelope of about 100 by 180 by 101 millimeters, or roughly 7 inches by 4 inches. This is one of EnvisionTEC's largest desktop 3D printers to date, and has plenty of space for dental models during their print. This is only 10 millimeters shorter in the X direction than some of the other pricey subscription-based printers on the market. So now, for me, the most exciting part of this presentation is the EnvisionOne RP software, especially for users that are currently using it. What is new and what is coming down the pipeline, but also for people that are, or for those of you that don't have the EnvisionOne software or don't have an EnvisionOne, well, what is it all about? Well, the EnvisionOne RP software was designed with intuition in mind. So the software itself has been simplified completely to be able to get the job done and as quickly and as most efficiently as possible. So all the necessary tools are readily available. There's no subfolders, there's no tabs for the actual 3D printing workflow. You can easily import a part, rotate, add supports, nests, and export the job file directly to the printer in a matter of minutes, or actually in a matter of seconds. So we do have hyperprinting and different methods of hyperprinting. Hyperprinting is EnvisionTEC's way of making the entire nesting process one click for every single user. So with Hyperprint, you literally load in all of your models. Let's say you're printing horseshoes for for aligner models, right? For Suckdown. So you import, let's say you want to import 10 models, but you can't fit 10 on the platform horizontally. So you want to print them vertically. You pull in all of your models. Again, the software automatically fixes everything and imports it for you. Then you click one button, which is the Hyperprint, and select A-type jaws, which A-type jaws, the only reason we call it that is because if you look at the horseshoe when it's standing up, it looks like the letter A. But you select A-type jaws and you hit apply, and it will literally take every single one of your models, scan them, It'll position them in the best Z-axis or vertical orientation to ensure accuracy, not only throughout the entire model, but also in the most important part that a lot of other manufacturers don't keep in mind. And I'm sorry, Chris, I'm not sure if I'm using the right term, but I believe it's the incisal edge or the lingual, the part that basically will droop down when the model is in vertical orientation. And this right here, when we place models in a vertical orientation, if we don't keep this in mind and we go straight vertical, if you do not have supports, then you are going to have a drooping or sagging surface. So again, the EnvisionOne RP software takes all of your models, checks for the best accuracy, puts them in vertical orientation, and does it all in one click of a button. So let's jump over to the next slide so I can give you guys an idea as to what that looks like. So if you see here, this picture here, right beneath the blog post, or right beneath the word blog, shows an automatic build of all vertical oriented models. This was all done with the software via one click. And again, this is extremely exciting for our software because it makes using the EnvisionOne that much easier. Now, what else are we doing? Well, we're working on a number of updates for our users to be able to bring more features to your computer or to your nesting process. Not only do we have labeling, not only do we have auto placement, not only do we have auto nesting, and we're creating a new generation of support widgets. I mean, there's a lot of features that EnvisionTEC is working on, and how do you keep up to date on everything that EnvisionTEC is working on and that EnvisionTEC is going to bring to market for you? Well, I do want to announce that we have a new EnvisionTEC support center, www.help.envisiontech.de. This website is really jam-packed with plenty of resources for our customers and also those that are interested in learning more about our technology. We have information from our latest line of printers, from installation instructions to maintenance and even frequently asked questions. It's all on this site. We also keep everyone up to date with our blog posts on this site with new upcoming features. So please keep an eye out for it. And if you can, bookmark it, because again, this is a great website that's going to be continuously built up and it's going to be kept up to date. So again, if you're even interested in knowing what EnvisionTEC is all about or what the printers are all about and how to set them up, how to get them running, how to work with them, how to use the software, if you want to see videos on any of our technology and how it's used, this website has all of that information. Also has PDFs, site prep guides, all of it. So again, I welcome you or I encourage you to go over to our website and check it out. Now, let's talk about one of our favorite topics here at EnvisionTEC, which is accuracy versus resolution. There has been before, I don't know if we've cleared it up today, but there has been before quite the confusion or quite the haze between what is accuracy and what is resolution. There have been competitors on the market before that have stated, oh, we can print 5 microns or we can print 15 micron resolution, and it's, to the ear, it sounds amazing. Oh, 15 micron resolution, that's great. Well, they're not really telling you how accurate it is. They're not telling you what the accuracy is in the X and Y. They're not telling you if it's even going to be good for your application. Just because I can print something at 15 microns, but my resolution or my actual accuracy is still plus or minus 150, 200 microns, then it's not going to be good for my dental application, right? So it's very important to understand the difference between accuracy and resolution. So accuracy is how closely a final 3D printed model measures up against that digital model. Usually, dimensional accuracy is measured in a XY tolerance or is reported as a total percentage of a scan accuracy against the model. The only way to determine actual accuracy is to print the part, scan the model, and compare the scans to the digital model. On the other hand, resolution for DLP and CDLM technology is just the fixed number of pixels on the display, or also how thin of a layer you can print, which again doesn't always contribute to your application. Just because you can print models and dies at 15 microns, but your XY your XY accuracy is 160, 150, 100, 200 microns, your crowns are not going to fit, your dies are not going to fit, you're not going to get an actual representation of that digital file. So it's very important to know the difference between the two and really understand what you're trying to buy or what you're trying to use for your application. So speaking of accuracy, let's talk about orthodontics. The American Board of Orthodontics was the first dental organization to publish standards for dental accuracy requirements for digital models and 3D printing in 2016. EnvisionTEC's internal accuracy standard is actually a bit higher than the ABO standard requirement of 99.9% accuracy within 200 microns. So we did perform a test to see how EnvisionTEC printers compared with some of our competitors in terms of accuracy with the exact same STL file printed in a variety of printers. And we're just going to show you guys a few of those scans, okay? So here we have the EnvisionOne CDLM or the EnvisionOne CDLM, yeah, DLP with E-model light DLP, horizontal. We're looking at an orthodontic model. Horizontal, we can see that 99.9% of those triangles are accurate within 200 microns. So that's the ABO standard, right? That's a pretty loose standard though. It works for orthodontics, but when it comes to EnvisionTEC, we like to keep things a little tighter. So as you can see here, we went down to 100 microns, which means that we cut that accuracy, or we made that accuracy twice as tight, and yet our model still maintained a 97% accuracy at 100 microns, which is great. So let me show you here on one of our competitors here, an SLA competitor. We see that the model is 70% accurate at 100 microns, while the EnvisionOne, again, you're looking at 27% more accuracy at the on the EnvisionOne CDLM, which is, again, it's huge. Now, let's look at the ABO standard, which is 99.9%. Again, it's not as tight of a tolerance, but it is what is their recommendation or their requirement for printing orthodontic models. The SLA, again, the XLA desktop printer, is at 95% accuracy, which again doesn't meet that requirement, while the EnvisionOne does it no problem. Now, orthodontic applications tend to have a little bit of a looser accuracy requirement. However, dental is much more stringent, or much more, what do you call it? The tolerance is much lower. So let's look at 50 micron accuracy. So if we look here on the EnvisionOne DLP, or I'm sorry, the EnvisionOne CDLM, printed in E-model light DLP, we printed this one model. 88% of the triangles were accurate at a 50 micron tolerance, which is extremely tight, right? I'm going to show you now the pricey subscription printer here, okay? This printer is extremely expensive, and it is a oxygen-based printer. And as you can see, we have quite the dome effect. And remember when I was talking to you guys in the beginning of the presentation of that dome that throws off accuracy and makes printing more difficult, why it's so important to have a domeless material tray. If you look here, that purple is because that dome is pushing up against the platform and making it much more difficult for that machine to keep accuracy. So again, we have 57.5% of accuracy at 50 microns on a very expensive subscription printer. And again, EnvisionOne, you can see the difference. It's night and day. I mean, look, it's almost completely green, 50 micron accuracy, 88% accuracy at 50 micron tolerance. This is really the difference here when it comes to domeless versus domed, and also accuracy versus resolution. Again, resolution is great. If you can print 15 micron layers, that's great. But is it going to be accurate? That is the important thing. All right. The floor is now open for questions. If you have any questions, please go ahead and type them in the chat. Chris, I'll let you jump back in if there's anything that you'd like to say.
No, thank you, Miguel. I'm anxious to hear any questions that our attendees might have. I always prefer more of the interaction than just me rambling on slide after slide, although you did a much better job than I, so thank you.
No, you're good, you're good.
Great job to you both. We do not have any questions currently in the chat, but if you would like to submit a question to either Chris or Miguel, please use the chat or questions functions, and we'll be happy to address those questions. We'll just give it a minute, guys.
Perfect.
Thank you. We're happy to hang out. Maybe we should do like school and start threatening to call on people and put them on the hot seat.
Hey, that's a great idea for future webinars.
You remember that from when you were in school? Uh-oh, I better come up with something or she's going to call on me anyway.
It seems like you all were so thorough that we do not have any questions at this time, but I am sure that our attendees will discover that they might have some questions when we conclude. So if you do, please don't hesitate to reach out to a Zahn rep, and we will be happy to address those questions or concerns. I want to thank you both, Miguel and Chris, for your time today, and thank you all for joining our webinar. Have a great day, guys.
Thank you. Thank you.
Thank you.
Bye.
Bye-bye, everyone.